So you want to build your first off-grid solar project, but you don't even know how to start. I mean, where do you even begin building an off-grid solar project? Well, today I want to talk about the 5 steps you need to build any size solar project. But I'm not just going to talk about it, I'm going to walk you through all 5 steps on a sample project. So, this is what I'm talking about. Today, I want to bring some electricity to my chicken coop. So, we're going to go through all 5 steps on a real sample project, so I'll show you how you can apply these concepts to any size off-grid project that you want to build. So here are the 5 steps to build any off-grid solar project. Number 1, evaluate your needs. Number 2, pick the right voltage for that project. Number 3, spec out the gear that's best for your project. Number 4, wire it all up. Number 5, that's going to be some tips and tricks that I'll talk about at the end. Let's start step 1 by evaluating my needs on this sample project. Well, I want to run a heated water in the wintertime. That's about 35 watts, so that's my power needs. But I want to run it upwards of 24 hours. So to get my energy needs, I take the power that I'm going to be using times time. That will give me the amount of energy I'm going to need to store. So for this project, a 12 volt, 100 amp hour battery will be fine. Now that I know my needs, I can move on to step 2 and pick the best voltage for this project. Now there's 12, 24, and 48 volt. 12 volt is the best for projects 1,000 watts or smaller. Now this is going to be well under 1,000 watts, so 12 volt's really my best choice. Let's talk about some other voltages real quick. 48 volt is really the best choice if you're building a big project. There's so many features and flexibility and expansion, and it's really the best bang for your buck, as in its most cost-effective solution to build. But of course it's the most expensive to build, and if you're building a small project, it's really over the top for what we're going to do. But if I was going to be building something 3,000 or 6,000 or especially a 12,000 watt system, like for my whole house, 48 volt would be by far the best choice. Now what about 24 volt? Well, I actually love 24 volt. I have 2 24 volt systems and they work really well, but I still think 24 volt is probably going to be too over the top for a system this size. So I'm going to stick with 12 volt on this project. So now for the fun part, get to spec out the equipment I'm going to use. Every single off-grid solar project you're ever going to build, no matter what size, something small like this or taking your whole house off-grid, you're going to need 4 components: solar panels, charge controller, an inverter, and a battery. So first up is solar panels. I'm going to talk about the solar panel that I'm going to use, why I chose it, and we'll go over a little bit about solar panels. That's a whole video on itself, so I don't want to get too far into it. There are a couple of things about the solar panel that I want to talk about that are important no matter what solar panel you pick. This is a 200 watt solar panel, so technically speaking, it's actually a little bit smaller than it should be. I have a 1280 watt battery that I'm going to use. So really, you're supposed to have a solar panel that will recharge it within 1 day. And I get about 5 hours of sun today, 200 watt panel, that gives me 1,000 watts. So really, it should be a little bit bigger, but this is what I have lying around, so this is what I'm going to use. So on the back of every solar panel is a little sticker that has really important information. So let's look at it. Right here it says open circuit voltage 21.6 volt. Now that's really important because the voltage of the solar panel has to be higher than the voltage of your battery. So this will be fine for a 12 volt battery. But if I had a 24 volt battery, 21 volts is lower, so it wouldn't be good enough. So I'd have to have 2 of these in series to make it higher if I was doing 24 volt. But because I'm just doing a 12 volt system, 21.6 volt open voltage circuit will be perfectly fine. The second number you have to pay attention to is how much current is coming out of it. And that has to do with how to spec out a charge controller, so we'll get into that a little bit later. This solar panel is perfectly fine to use. It's what they call a P-type solar panel. Now there's another type called N-type that tend to be a little bit more efficient. I actually prefer them. Again, this is what I have. This is a busless design. So the front, it looks like just a big black sheet of paper. There's no little bus bars on it. So I kind of like that, but I would prefer to use a bifacial N-type panel if I had an extra one of those lying around. But again, this is what I have. It'll work perfectly fine. So that is what I'm going to use. So the next component we're going to talk about is a solar charge controller. Your solar panels come into this. This regulates them and then it brings it into the system. You want to use an MPPT style charge controller. This one says it is. Frankly, I don't think it is, but it's an extra one I have lying around. I would not recommend using that, but again, this is what I have. Use a Victron. Just save yourself some headache. Just use a Victron. They're by far the best ones out there, but this is what I got. So there's some numbers on this one too that you got to pay attention to. Remember we talked about the little sticker on the back of the solar panels, the little amp thing? Well, on the back of that solar panel, it says it can do 10 amps. So you got to make sure that 10 amps matches this. So this sticker says it can do 60 amps, which again is kind of crap. It doesn't do 60 amps, but let's hope that it actually does 10 amps. But you want to make sure the amperage, the voltage, and the watts of this match your charge controller. So this one says rated voltage 12 or 24. So I could use it on either a 12 or 24 volt system. We already talked about the rated current. It says it can do 60 amps. Again, I think it's crap, but whatever. The next thing is the voltage. Remember that one said 21 volts? This says it can do up to 50 volts, which again, I think is crap, but we're just running on the numbers. So this one, technically speaking, will work with that solar panel. So it says maximum power on 12 volts, 760 watts. That's a 200 watt panel, so it should be fine. Now this is where if you had a 24 volt system, you actually have an advantage, because if you had a 24 volt system, you could actually do 1500 watts. So you can actually double your output if you have a bigger system. So that's why I like doing 24 volt systems. Although again, for this small little setup, 12 volt is perfectly fine. Just to recap though, this is what I'm using because I got an extra one of these lying around, but this is a cheap $20 one that I got off of Amazon. Get yourself a Victron. They're just so much more powerful. They've got all sorts of analytics in them. They got Bluetooth. They're just so much more powerful. I really don't like this, so I'm not going to recommend it, and I'm not going to include a link below. But you will need a solar charge controller, and the numbers need to match both your system and especially your solar panel. Next up is the inverter, and this is for taking the DC power and turning it into AC power. But you may not need this, and let me explain why. So let's say you have a DC system and you only are going to use DC stuff, like you have the battery and you're only going to run like a DC light. You don't need to use that inverter. That's only if you need AC power. If you're just going DC to DC, you can actually take your charge controller, and right here there's actually a load. You can actually hook DC stuff directly up to that. So the inverter is only necessary if you're going to be running AC stuff, which we are going to be running. So now a little bit about how a battery works. So I've already mentioned that a battery is going to store DC energy. You can't store AC energy. All stored energy is going to be DC. So if you want to plug in stuff like any kind of appliance you have in your house, you need to change that DC energy coming in into AC energy. And that's what this thing does. Now there are several different types of inverters out there. This is what's known as a high frequency inverter. So what it does is it takes this stuff, and there's a bunch of little switches in here, and it switches it back and forth, back and forth, back and forth, back and forth, and then it turns it into AC, filters it, sweetens it, cleans it up, some safety features to make sure there's no problems, and you have AC out. Now if you were going to be running something huge, like a big well pump or huge air conditioners or something like that, you could actually use what's called a low frequency inverter. That does kind of the same thing. It's got a bunch of little switches in here that switch it from DC to AC, but there's a big transformer in here, and so that transformer isolates the DC side from the AC side. So the only thing is they tend to be expensive and they tend to be kind of heavy and clunky, so way too over the top for what we're going to use. A good quality high frequency inverter like this is perfectly fine, but don't use a cheap low frequency inverter. If you use a cheap low frequency inverter, some of the electronics in here can be poorly designed and can actually cause problems. So this side and this side aren't isolated, so if there's a problem over here, it can actually hurt your AC devices. So never buy a cheap high frequency inverter. This is a Gandel inverter. It's solid. I love it. I've been using them for years. So let me talk a little bit about the numbers. So you got to make sure your inverter matches your system. We're building a 12 volt system. This is a 12 volt inverter. You also got to make sure that your power output matches your system. This can do up to 1200 watts. Remember, we're going to be pushing 30, 40, 50 watts. Even if I upgrade and add other things, I might be pushing a couple hundred watts. So really, I could use a much smaller inverter. But This is what I have, so this is what I'm going to use. And also, this is something to consider whenever you're building a system, is build a system a little bit bigger than you need now. You always want to think future. Gandil makes really inexpensive, high-quality inverters, but they're still a couple $100. So if you build a system and you outgrow your inverter, you got to just toss the inverter and get another inverter. So that's why I always say get an inverter that's a little bit bigger than your needs and grow into it. I would recommend for this particular setup to use more like a 500-watt inverter. That would be plenty for this size system. But again, this is what I have. It's a solid inverter. Love it. So this is what we're going to be using. So what the is that? That is probably what you're thinking right now. This is a battery. It's a homemade battery. You don't have to use a homemade battery. You can just go out and buy a normal battery, but you want to make sure your battery matches your system. So this is a 12-volt lithium iron phosphate battery. It is a 200 amp hour battery. So it's actually bigger than I remembered. I thought it was a 1280 amp hour battery. It's actually a 2500 amp hour battery. So it's way, way, way over the top for what we need, but it's the only battery I got lying around. But you don't need to use a battery this big. This is just what I'm going to use. But I'm going to talk about some of the features of this battery. This is a Bluetooth dongle. So you can actually use your smartphone to watch everything that's going on in the battery. Now, every battery, whether you build it or you buy it, has a BMS in it. And what the BMS does is it controls everything about the battery. Make sure it doesn't get too hot, make sure it doesn't get too cold. And I say cold because lithium iron phosphate chemistry can't be charged when it's freezing out. So it protects the battery. If the temperature gets too cold, it says, nope, 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 nope. It shuts down the battery. On the other side, if it gets too hot, 130, 140 degrees, it says, whoa, too hot, shuts it down. Also, when you're charging it, let's say that energy coming in from the solar panel becomes too much, it says, whoa, we're full, stop. And then on the other side, if you're discharging it and you forget and you run it too long and it gets too low, it says, hold up, we're too low, and it shuts it down. And it also balances all four of these cells to make sure they're even as much as they can. So it really protects the whole battery. Another thing to point out is this right here. This is a terminal fuse. You have to have a fuse, and we'll get into that when I start wiring it, but I can't stress that enough. Make sure your battery and the rest of your system is fused. So those are the four components that we're going to be using. And no matter what you build, whether you're using a small portable power station, or you're building a small system like this, or you're building a big system to run your entire house, every off-grid solar setup has the same four components. They can be bigger, they can be different quality, but they all work the same basic way. So that's why I'm saying this video, yeah, I'm making it for a chicken coop, but you can take the ideas I'm talking about in this video and make any size system. Just make it bigger to match what you need. Now let's go put this thing together. So here are three of the four components. The solar panels will of course be mounted out here in the sun, and a wire will run over. What I did is I grabbed the front panel of an old power station that I built because I want to have an ability to turn the whole unit on and off, and I'd like to have a way to turn the inverter on and off remotely. And now I'll show you how to wire it all up. So I got my bus bar mounted, and now I can run my wires. But before I do that, I want to talk about wires. So you come down here, you see this big thick wire, then I have this little teeny wire. Let me tell you why I'm using those wires. So let's go back up to the inverter. You can see it's 1200 watts, and this is a 12-volt system. That means the maximum current that could run through this system is 100 amps. So I got to make sure my bus bars and my wire are rated for that. So this is a 100 amp bus bar, and this is 2 gauge. This thick one is 2 gauge wire, which can handle well over 100 amps. So even though I'm never going to be running 100 amps through here, I want to build this like I'm going to be doing that. Now let's talk about this little thin wire. Now this is 12 gauge THHN wire, and that can handle about 20 amps. And that's going to be going from the charge controller to the bus bar. And of course, the positive will go from the charge controller to the positive bus bar, which I haven't mounted yet. But that's just a real quick thing about wires and bus bars. You want to make sure they match your system size. The actual wiring of this is pretty straightforward. I'm going to take my wire that I just talked about, come over here to my charge controller. There's 3 sets. This will go out to the solar panels. There's a little icon, there's a little battery icon, and then there's a load icon. Now we talked about the load icon. If I wanted to hook up DC stuff directly to that, I could do that, but I'm not going to be doing that. So I'm going to take my black, which is my negative, insert it inside this little gate. It's a little negative symbol. Put it in, tighten it down with a screwdriver, and give it a little tug, make sure it's snug. Then we come over here, take this off. When I'm done with all my wires, I'll secure them so they're a little more organized. And I'll also tighten this down. Right now I'm just going to hand tighten it. And then we're going to take this one, again a 2-gauge wire. It's going to go to the inverter. Whenever you put wires on top of wires, you want to have the bigger wire on the bottom. So that is the negative roughed in. So now we're going to do the positive side. I'm going to take a wire, red, from my fuse to this switch. This will let me isolate the entire system. So this will go on in there. And I'm just going to hand tighten them for now. Now I was going to use a positive bus bar, but I think I'm just going to use the switch as bus bar. I'm just going to hand tighten everything. We'll finalize everything when I'm done. Now I'm going to wire from the switch to the inverter. I'm going to take the positive charge controller to the switch as well. So this is another THHN wire. I put red on it so everyone knows it is positive. And again, I'm going to put the smaller wire on top of the bigger wire. Hand tighten that down. Again, we're on the battery side, positive side. Open up that gate and close that down. Give them both a good tug to make sure they're not going to come out. And there we go. We'll clean these up a little bit later. So now the final step is to wire up the solar panels. And it's the same thing, you just open the gate, positive, positive, negative, negative, secure them down, give them a little pull, make sure they're snug. Well, that's it. The system is wired. And as you can see, it's a very simple project to do. A couple things I want to talk about. First of all, the charge controller. Remember I was talking about using a Victron? Well, this cheap Amazon charge controller failed before I was even finished. So I'll say it again, I should have listened to myself. Use a Victron charge controller. They are just so much better. They save you a lot of hassle. Another thing I want to talk about is circuit breakers. As you can see, I have two different types of circuit breakers here. So this is a high voltage circuit breaker, and this goes between the charge controller and the solar panels. And I'm not going to show you how I wired it because each one can be wired differently. So if you wire it the way I tell you and you buy a different model, it can cause a lot of problems, including fire. But you have to have a high voltage circuit breaker. Now this goes up to 48 volt, so you can't use it on solar panels because even though this system is low voltage, 21 volts like we talked about earlier, so I mean theoretically I could use this in this system, but in general solar panels are going to be high voltage. They can be hundreds and hundreds of volts. So this can take up to 1,000 volts, so you want to make sure you use a high voltage circuit breaker and make sure the amperage is rated for your system as well. Don't use a 48 volt or smaller circuit breaker for your solar. This is good for separating system components, and if I wanted to, I could wire it in between my charge controller and the rest of the system. That way I could turn it on and off if I wanted to. If I did want to do that, a couple things. First of all, I want to make sure that the amperage, 250 amp right here, you want to make sure that the amperage matches your system. So of course the 250 amp would be way too big for the system. Also, you want to make sure you get a quality one, either a Blue Sea system or a Busman. So make sure you get quality circuit breakers and don't interchange circuit breakers. These two circuit breakers have totally different functions and are not interchangeable. The next thing I want to talk about is grounding. Come over here. See this is for grounding the inverter. Now I'm specifically not going to talk about system or equipment grounding because every system can be a little bit different. So if I show you a way to do it here and you apply that to your system, it may not work. So always follow the recommendations of the manufacturer of your equipment for system and equipment grounding. The final thing is, and this is kind of obvious, this is outdoor and temporary. I'm really going to put this in here, but there's a couple reasons why I didn't for this project. First of all, I have to clean this building out still. It's full of junk. The second thing is the lighting's just better here, so it's much better to film it here. Of course, this is exposed to the elements, so this is for demonstration purposes only, but I did want to film it here so you could see the components much more clearly. Well, now let's turn it on and see if it actually works. So we're going to turn on this, and you can see the it sees the charge controller. Turn this on. There's a load going through. The final thing we're going to turn on is the solar panels. Now it's early in the morning, so we're not going to get a lot of solar energy. Let's see what the old Victron is saying. So you can see there is actual power coming through. Not much, about 12 volts. Remember, we have 200 watt panels, so we should be getting close to 200 watts on the total. I'm going to see what the battery says. So the battery says there's load. I have the little light hooked up. So we have a complete functioning working system. So that's it though. I mean, you can see it's not that difficult to wire up a small solar project, and you can take these ideas, these concepts, the fusing, the circuit breakers, the components, and make any size system you like. Now for step 5, some tips and tricks. First off, on solar panels. You need to have solar panels at the correct angle and tilt to work properly. And the best way to do that is to get a can and to put it on top of it and to move it around until there's no shadows. And that way you have the best angle and tilt. Another thing is whenever you're going to mount your panels, remember that you're going to have to do some maintenance on them. Minimum is you're going to have to keep them clean. So if you're somewhere dry, like the desert, and they get a lot of dust and debris on them, they need to be cleaned off. So if they're mounted somewhere high up on your house, that's going to be problematic. And then on the opposite side of that, if you're somewhere cold and snowy and you get snow on them, you need to have a way to get the snow off because they're obviously not going to work with snow on them. So a tip for batteries is use a generator to support the batteries. So when you spec out your system, you don't have to buy a ton of batteries. You can buy it for your average. That way, if you do go an extended period of no sun or extra usage, you can use a generator to supplement them. Unless you have unlimited money, then buy as many batteries as you like. I already mentioned this before, but think about your future expansion. Whenever you're building out a system, think, okay, this is what I'm using today, but what am I going to be using in a year or 2 years? Am I going to have different needs? It's because if you do buy equipment now and it's limited and you reach the end of it, it can be expensive to replace it. So always kind of buy a little bit more than you think you're going to need, especially with solar panels. Get as many solar panels as you can. Now, the final tip to me is obvious, but a lot of people don't think about this. If you build an off-grid system, you're the power company. So you really need to know all the system. You could buy an off-the-shelf system and a rack-mounted battery and plug it in and not really understand the components. And then if something happens, you kind of left to your own devices. Where if you do a DIY build and you put all the components together and you know how they all work together, if something happens, you can troubleshoot it more easily and you can fix it more easily. So just think about that, because you are the power company when you build your own off-grid system. So if anybody has any questions or comments about anything you see, please leave a comment below. As always, like, comment, share, subscribe. Really helps out the channel, and I will talk to everyone soon.